Hello, Internet! Today we're gonna continue our short series about explainable AI. And today I want to show you two different kind of AI systems. And at first we have a big monolithic AI system like we have with our large language models, our LMM, like GPT-3, or as Stanford High calls it, the foundation models. And then we have another model, which I call a smart, intelligent modular system, where we have some vision AI system, where we have some text-based NLP AI system, and we have a graph AI system where we have some environmental metadata, meta-class data for our system. And you might ask, hey, why do we look at two different kind of system? And I will show you that there are significant differences between these two systems, especially regarding the complexity, the costs, and whatsoever. So let's start with NLP. And you can have either a huge system, and this is the one indicated at the bottom on this slide, where you have all the millions and billion sentences of all Twitter accounts, of all Facebook posts, of everything that has been done on Reddit, and you want to catch all of the human comments that are available, and you have this large LLM where you have 1.6 trillion word tokens for your transformer model, for your LLMs. And on the other side, you have some very specific small models. And these small models, you can have the preprints from some physical archive, for some chemical, or for some biological scientific literature. It all depends on you. And you see, the system also are different when it comes to how you construct the system, and what about the interwoven complexity of the system. But at first, let's start with the API. And if you say, but where I get 100 latest publication preprints for physics on a specific topic, here we have ArXiv. I highly recommend it. It is a preprint server where you have almost all of the scientific literature as a preprint before it is published in the very expensive journals like Cell or Biology or PhysB or whatever the letters are you're interested in. So, and with this simple line of codes, if you're on Python, this is a Python library code. The libraries are already included in your Python 3, and with this 2, 3, 4 line of codes, you can find the latest publication here, for example, AP query for electrons. But if you have now 100 documents, what do you do with it? And I want to show you here in these slides that I have, let's say, the latest top 100 preprints, scientific preprints on the topic of decision artificial intelligence, decision AI. And what you do is you find a source you can trust. And this is, for example, an archive server where you download the PDFs of this documentation. Now, the PDF are in a specific format, so you have to convert the full text PDF to plain written English text where you have all the sentences. And then when you have, I don't know, 100,000 sentences or 1 million sentences on your specific topics, you can start to deploy the normal NLP system you are familiar with, a BERT transformer model. You can have, I don't know, a clustering of the specific topics. What are the main topics in current research publication, preprints on physics, on biology, on whatever you're interested in. Even computer science is part of the archive system. So you can learn about the latest development. You can cluster it, you have a reduction in the dimensionality, you can create a three-dimensional graph, and I did several videos on the specific Python code on the Jupyter Lab notebooks that do exactly this, and that gives you a three-dimensional representation of the BERT clustering based on sentence BERT transformation on the sentence embedding in a lower dimensional Euclidean space. But of course, there are other possibilities. You can take an already pre-trained system, let's say a Roberta system from Hugging Face. You download the system, they are normally between 3 and 5 gigabytes. And then you can additionally train this pre-trained BERT system with your domain-specific data. So your 100 latest scientific publication on, let's say, electron physics, you can have those data sets in addition to the pre-trained data sets, and you can perform a new training cycle and also have a video where I show you how to code this step by step in a Jupyter lab with Python, so that you finally have an AI system that is fine-tuned to a particular physics topic that you are interested in. And of course, the more memory you have and the more access you have to cloud computing resources, you can make bigger and bigger systems. But the beauty in all of this is you can fine-tune and develop models even when new algorithms came along for a specific topic. And I want to show you in the next part, I want to give you two examples. The first example is that the Sentence BERT embedding methodology, the algorithm, the Python algorithm, there is now proposed a new way to even outperform for a specific task GPT-3, a very large language model. And the second example is, since we are here on the topic of explainable AI, I want to show you that there is now from Google Research a new approach in NLG, so natural language generation. If you want to have a summary of a text or a document or a paragraph or a book that is automatically generated by some artificial intelligence system, that they propose a new attribution mechanism. So here we go with our two examples. Let me show you this article in towardsdatascience.com, where in December 2021, Moshe Wasserblatt published the following article, that there is a sentence transformer fine-tuning methodology he calls SetFit that is outperforming GPT-3, but on a few short text classification tasks. So on a very specific task, he says, hey, I found a methodology to improve the sentence transformer with some fine-tuning so that I outperform the large language model GPT-3, although I am 1,600 times smaller with my model than GPT-3. And this is a beautiful example how you can improve known elements in, let's say, sentence transformer. And this was done in December 2021. I don't want to go through this in detail, but as you know, sentence transformer, I did several videos on the sentence transformer and showed you the Python code for programming your own sentence transformer. The idea is that you adapt the transformer model in a Siamese architecture, you can see here, and then you minimize the distance between semantically similar sentences, and you maximize the distance between sentences that are semantically distant. And you come up with sentence transformers. And their main area of application, as I showed you in my videos, is semantic search, semantic similarity, and clustering of all sentences. So with clustering, you can find specific topics. With the similarity, you find sentences that cover the same topic. Let's say you have something in physics and you have some other facts in, I don't know, biology. With semantic similarity, you find out if there's a bridge between physics or chemistry or organic chemistry and biology. And of course, semantic search if you have question and answer sessions. And now the idea is, where is it? Here. that SetFit, this new methodology, the fine-tuning, is training and inference phases, and I don't want to go into the detail. There's a simple model. He gives us a generation pseudocode we can run through. But since I did not find a specific archive preprint on this research topic, I'm not sure right now what to think about it. If you Google Moshe Wasserblatt, you find out he is working with Intel and he is working in the Intel AI labs. So sounds interesting, but I have no information about him. I could find no other publication in the archive, in the preprint servers, and I do not have access to the very expensive official prints or official publications in Nature or whatsoever. So therefore, this is just an example that you can increase significantly the performance of known elements a little bit by bit, buts and nulls, and then you even achieve some outperforming the huge LLMs models like GPT-3 on specific tasks. The next article I'm going to show you will be about NLG, and it's a very short interrupt. I just want to give you a 1-minute intro. What is NLG? And as you can see here in this article from July 2021 by AI Multiple, natural language generation, NLG, is what it is and how it works. And they say artificial intelligence is disrupting industries with use cases and content automation. Rather than writing thousands of descriptions for the catalog, e-commerce companies are relying on NLG to convert structured data like product specification into a description that is easier to consume for humans. Is the technology behind text content automation with its capability to convert data into words, sentences, articles. So, NLG is a subcategory of NLP, natural language processing. I already showed you in different videos, and it's a software process to automatically transform structured data into human-readable text. Text 6 stages: content, data interpretation, document planning, sentence aggregation. Maybe this is nice, where different sentences are aggregated in context because of their relevance. So we have a summation task. You have to summarize, let's say 10 or 15 sentences, and then define what is the content of those paragraphs, for example. Grammaticalization, yes, retail, wholesale, manufacturing and media, all the different industrial sectors, yes, yes, yes. What are the real-world content automation examples thanks to NLG? And he gives a short description of the options, and GPT-3 here, which I already talked about, is the most recent news in content automation. Well-written narratives. It lacks logical understanding. Well, of course. Makes articles prone to error. Well, yes, of course. So you have a feeling what is NLG? It's a subtopic of NLP, and it is a real-world content automation. And GPT-3 has been in the news, and you know about GPT-3, our large language model. This is it, and now to the original article. I really wanted to show you about Google Research, what they came up with, the new developments. And here we are now with our article from Google Research. These are our authors from google.com, and this was published as a preprint on December 23rd, 2021. So our Christmas present from Google Research for Christmas 2021. And they specify here measuring attribution in NLG models. Now, abstract. They say recent improvements in NLG models. Yes, beautiful. We have to have means to identify and evaluate if the NLG output, so whatever comes out from our artificial intelligence system, is only sharing verifiable information, real information about the external world. And they say here we present a new evaluation framework, an evaluation framework, and this is important, entitled Attributable to Identified Sources, ACE, for assessing the output of NLP generation models when such output pertains to the external world. And they empirically validate this approach on 3 datasets via, and this is important, human evaluation studies. So the humans characterize if the output is good or approachable, and if ACE could serve as a common framework for measuring whether model-generated statements are supported by underlying sources. And they have also some guidelines for the human evaluation studies, because of course humans have to judge, hey, this model produces an output that makes sense, or this is complete rubbish. So, introduction. Great, impressive results. Yes, 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 but the systems lack faithfulness to underlying sources. For example, in summarization or in grounded dialogue systems. So what they want to find out is, hey, how can we optimize this system? And if you want to read a little bit about the background in chapter 2, here it is for you. And what I want to show you now is a formal definition by Google Research of attributable to identified sources. This gives us a formal definition of ACE, attempting to give a clear and precise definition of attribution. And so here we go. The first thing is a standalone proposition. So simple sentences that are self-explanatory. Let's take here sentence 1. George Harrison was 25 years old when his album Wonderworld Music was released. So this is a standalone proposition. We have everything. We have the subject, we have some information, what happened when, and a complete different sentence. Sentence 2, he was 25 years old. Now we can say here in S2 is, however, not a standalone proposition, as it cannot be interpreted without additional contextual information. It is context what he refers to. And also S3 is not a standalone because it lacks details of historical content. So George Harrison was 25 years old, yes, but when? When was this article written? What is the time horizon that it refers to? So you see, these are the problems. And now Google Research comes up with a definition for some attribution to explainable. Explainable sentences? No, my God, I forgot the title. Explainable? What is as identified sources for identified sources? And the topic is explainable AI. Oh, Jesus. So here we go. Definition. As for standalone proposition. A pair, S and T, where S is our standalone proposition, could be a sentence, as we just showed you, and at time T is, so something is attributable to identified sources if and only if the following condition holds. The system provides a set of parts of some corpus K along with S. So we have some additional information. And then we say the set or the pair S and T is attributable to a part P. So a pair is attributable to a set of parts P of some underlying corpus if and only if a generic hero, and I suppose this is a human generic hero, will, with a chosen level of confidence, now it becomes a little bit wishy-washy, a chosen level of confidence, 50%, 78%, 92.8%, affirm the following statements. According to P, S, where S is interpreted relative to time T at time T. So you see, whenever we have this human including definition, this is really something you have to be careful with. But you know what? read it yourself. I'll leave you the link to this preprint, to this pre-publication in the description of this video, so you can read it in detail, some further definitions, and you can understand what they're trying to do, because I think if there is a summary, some word is a summary. Yeah, of course, you have a human evaluation study. We evaluate the feasibility of human eyes assessment for 2 tasks, for conversational question answering and for text summarization. So this is exactly what we're interested in NLG. Is all the information relayed by the system interpretable to you? Whatever, yes, but where is the rating, the limitations? Yes, no question, we greatly reduce the complexity. Well, of course, but what is yes and no? Huh? Tell me. Experiments, generation results. No, deeper. Where are the real? Come on, where are the real results? Example? No. References. Here, conclusion. What can we conclude about this? We define a new evaluation framework, an evaluation framework called attributable to identified sources. My tongue is breaking. Which allows us to inspect whether information in generated text by NLG, by AI, can be supported by source documents. Now, if you have a human oversight, you have, I don't know, a complexity, your document sources, I don't know, let's say you have 100 books or you have 10,000 articles. But imagine you have 20 million articles. How do you want to be able to scale this up that the human evaluator can really say, hey, this output of this AI system really refers to my document 2,600,852. I think this is a rather a limited system. It is interesting in itself, but can you scale it up really to large language models? Remains to be answered, maybe by you. So this was it to show you about current ongoing research in Google research about this problem of NLG, and what they say, hey, we want to find a framework, an evaluation framework, so that we can evaluate if there is an explainable AI system in front of us and how good this system is, and therefore we have an evaluation framework developed at Google Research. So, coming back to my original slide, of course, you noticed that in this modular AI multi-system, there was something I called alpha. And maybe you ask yourself, hey, what is alpha? Well, of course, alpha is the coordination unit between the vision AI, the text AI, the graph structured AI, content information. Alpha should be the master head above all these. So whenever there is a vision that you analyze, let's say a picture you take, or when you're driving an autonomous car, you have additional information about the object you identify. Let's say it is a child playing right next to the street. You can have access to your NLP library or AI trained system to identify what could happen to a child. And given that the entity abstraction from NER or from Sentence BERT, you can apply then, relying on your graph AI, what a child is a subclass of a human, and a child is irrational, a child has movements that are not dictated by logic, can't be spontaneous, a child has the danger of crossing the street. So you can deduct with an overarching AI that there is a potential risk that you should reduce your speed of your car, and that you should take special care when passing by a child playing right next to a street. Of course, this would be the topic of a very next video, but for the moment, I say thank you for watching, for listening, and I see you in the next video.